This video is about gravimetric analysis. At the end of this video, you should understand the principles of gravimetric analysis and be able to perform calculations relating to gravimetric analysis. Let's start with a definition. Gravimetric analysis is an analysis method based on mass. While there are several different types of gravimetric analysis, the precipitation method is the most common and the one that we'll be using in this class. In the precipitation method, an unknown is isolated by precipitation and filtration. We then take the solid product that we filtered out of solution, dry it, and take its mass. You might recall in previous labs that we've used the term heat to constant mass. This is a technique to ensure that all the water has been removed from the sample. Heating to constant mass involves heating the sample, weighing it, then heating again and weighing again until the mass stops changing. When the mass stops changing, we know that all the water has been evaporated from the sample and all we're left is pure sample. Here's a schematic showing us a particular example of gravimetric analysis. In this example, we're attempting to precipitate out all of the lead 2+ ions in solution. First, we take a sample containing lead 2+ ions and some other chemical species and dissolve it in water. Once it's dissolved, we add another aqueous solution that contains an ion which will form a precipitate with the lead 2+ ions. In this case, that ion is sulfate. The sulfate combines with the lead 2+ to form solid lead 2 sulfate. This solid can be easily filtered out, dried, and weighed. The mass of this solid can then be used to determine the amount of lead 2+ in the original sample. When conducting a gravimetric analysis, you'll need to perform stoichiometry calculations once you've determined how much solid you've formed. Take this question for example. Here we're asked to calculate the mass of solid product formed when 1.5 liters of 0.5 molar NaOH is combined with 2 liters of 0.1 molar MgCl2. I've outlined the steps below. We'll start by writing a balanced equation. This will help us determine what the solid product is. Then we'll determine the limiting reactant, and finally we'll calculate the mass of the solid. So step 1, writing a balanced equation. Here we see that 2 moles of sodium hydroxide react with 1 mole of magnesium chloride to yield 2 moles of sodium chloride and 1 mole of magnesium hydroxide. Notice it's magnesium hydroxide that's the solid here. Therefore, that's the precipitate that we'll be massing. We know this is the precipitate because most hydroxides are insoluble. Now, for step 2, we need to determine which reactant is limiting. I'll do this by first determining the moles of sodium hydroxide and the moles of magnesium chloride used in this reaction. Since I have a concentration and a volume, I can use the molarity equation to determine that I have 0.75 moles of NaOH and 0.20 moles of MgCl2. Using the stoichiometry of the balanced equation, I know that I need twice as much sodium hydroxide as I have magnesium chloride. So, looking at my magnesium chloride, which is 0.2 moles, if I multiply this by 2, I find that I need 0.40 moles of NaOH. Clearly, I have far more than 0.40 moles since I have 0.75 moles. Therefore, MgCl2 must be my limiting reactant. From here, I can use the mole ratio from the balanced equation to determine how many moles of magnesium hydroxide I can form from 0.20 moles of magnesium chloride. Based on our balanced equation, I see that it's a 1-to-1 ratio. Therefore, 0.2 moles of magnesium chloride will give me 0.2 moles of magnesium hydroxide. Multiplying this by the molar mass of magnesium hydroxide, I get 11.66 grams of magnesium hydroxide, or rounded to 2 sig figs, 12 grams of magnesium hydroxide. Here's another example to try on your own. Here you're asked to determine the percentage by mass of calcium in a limestone sample. Pause the video here and work through this problem. When you come back, I'll reveal the answer. Welcome back. You should have determined that 38.1% of that limestone sample was made of calcium. The work is shown here. Here's another example. Again, pause the video, work through the problem, and when you return, I'll reveal the answer. Welcome back. You should have determined that 4.9 grams of magnesium sulfate septohydrate are necessary to precipitate out all of the phosphate ions from this solution. That brings us to the end of our video. Let's review our goals. First, we looked at the principles of gravimetric analysis, an analysis technique based on mass. Then, we looked at how to perform calculations relating to gravimetric analysis.